In today's webinar, we will try to find out just that. Not only will we try to understand what is machine learning, but we will also learn about some of the applications of machine learning and how machine learning is being used in the real world. So without wasting much time, I will request Paul sir to begin with our college prayer. Paul sir, over to you.
A very good evening to one and all present here. Myself, Ms. K. Priya Karunakaran, feel honored to introduce our speaker for today, Ms. Anuradha Srinivasa Raghavan. Ms. Anuradha is Associate Professor in the Department of Computer Engineering at SFIT. She has been associated with our college since 2004. She has completed her B in Electronics and Telecommunication from Hindustan College of Engineering in 1991 and her Masters in Computer Engineering from Thadumal Shahani College of Engineering in 2008. Her skill sets include database management systems, data warehousing, data mining, artificial intelligence and soft computing, machine learning, big data analytics, and data science. Ms. Anuradha has published 20 papers in international conferences and journals and guided 4 PG and around 35 projects under UG level. She has authored the book Machine Learning under Wiley Publications in January 2019. She is also a Google certified trainer. Ms. Anuradha has been a resource person for various training programs in various colleges in and outside Mumbai University. The list is actually quite lengthy. However, I would like to mention the webinar conducted by ma'am on the topic, Can Machine Learning Aid in the Prediction of COVID-19? Which was organized by SGSITS Indore, where there were more than 1,000 participants. She was the keynote speaker for a national level SAGE multi-conference in Sagar Group of Institutions in June 2020. We are indeed happy to have such an experienced person to guide us in this field of machine learning through this webinar today. We welcome you, ma'am. I would request you to take over the session.
Thank you, Priya. It was indeed a very happy, and I'm really taken by the introduction which you have given. So I'm really happy about it, and I would like to thank the library committee for giving me an opportunity to address the young and inspiring minds who just want to know what is it. It is something everybody is talking about. Everybody is talking about data science, AI, and ML. And it is like you need to know because the future is that. But what exactly it is? So I'm very happy to ignite the young minds, because then after getting a spark, you will take it further. So I'm happy if at least by the end of this 1 hour, a couple of students get ignited and develop a passion for learning more about machine learning in future. So let me share my screen. Is my screen visible in both the places?
Yes, ma'am.
Yeah. No echo, right? There is no echo now.
No, no.
Yeah, thank you. Okay. So the topic which was given to me was machine learning applications in real world. Well, the as we progress to this 1 hour, it would be like a storytelling. You will start realizing that whatever you see in day-to-day life, it has an aspect of machine learning in it. You will start realizing that whichever medium you use in your day-to-day living, you feel that some aspect of machine learning is associated with it. So let me start with, what do you mean by machine learning? As a literal meaning of it, machine learns. But why should the machine learn? We have human beings. We are capable of doing so many tasks. And we are the ones who have invented the concept of machines. We are revolutionary in developing new things. But why should we impart some intelligence to machines which hardly obey our instructions and it work upon our instructions? The concept is simple. As and when you start automizing things, the data generated becomes really massive. So, what do you do with this massive data? You have to get the information out of the data. But what do you do with that information? The information has to be converted into knowledge, because it is this knowledge which will be useful from the massive amount of data which is stored. So machine learning is one which turns this data into information. And finally, from information, It churns it into a knowledge. If you see, for knowing machine learning, it can cross across any part of engineering. If you are a mechanical engineer, you require a concept of machine learning. If you start working with your mechanical equipments, which is following the industry 4 standards, like if you want to automate things, a certain amount of machine learning is required. Likewise, in the case of electrical, the electrical discipline also, wherever there is automation, wherever you want a additional machine to support the human power to do things in a much efficient manner, in a much quicker manner, a portion of machine learning is involved in all those places. So it is cutting across different disciplines. You need to be a good statistician. You need to have a good idea of probabilities. You need to know any engineering. It depends on where you use. You can use it in healthcare domain. You can use it in finance. You can use it in mechanical. So the list goes on. So it is an intersection of an engineering discipline with a knowledge of computer engineering, because the machines have to be trained, it has to learn. So you require a basics of computer engineering programming plus statistics, because you need to the machine you need to analyze whether the outputs are correct or wrong. So a basics of statistics is required. So it is applied to many fields, from politics to geosciences to genetic engineering to personalized medicine to analytics. You name the field, an aspect of machine learning is definitely in that particular field. So any field that need to interpret and act on data requires machine learning. So now telling so, you would have constantly heard of the terms AI, machine learning, data science. Those who are new to it will definitely get that doubt. What is this? Are they all related or are they distinct? What is the significance? For being a data scientist, is it mandatory I should know machine learning? For working in AI, should I know machine learning? So those questions really crop up. Because when I started studying machine learning out of my passion, my immediate doubt came. Well, I know data mining, I know some algorithms in it. The same algorithms are applied in machine learning. So is it one and the same? Then why it is given in two different headings, as data mining is separate and machine learning is separate? Then I came to realize, although things might look almost same, it is different. So, artificial intelligence is imparting intelligence to machines and automating it, like your autonomous car. Wherever you require an automated service, artificial intelligence is used in those places. But how do they learn? They learn using the concepts of machine learning. So machine learning are the algorithms which are used by the machine to learn of its own. And what is the output of it? The output of it is an autonomous system which is used, which comes under the umbrella of artificial intelligence projects. Then what is data science? Data science is an umbrella. Under data science, it is something to do with a vast collection of data. The data can be full of with immense volume, with different variety. What do you do with the data? How are you going to convert the data into a useful form? The entire umbrella of activity is a data science. And since machine learns from the data given under it, machine learning comes under a part of data science. So this difference is very important, because throughout you will be hearing that there are lots of jobs in data science, there are jobs in AI, there are jobs in ML. Then that confusion comes. Is it sufficient if I learn ML, I will be able to apply for jobs in data science or AI? What is the difference? So that is why, while introducing the concept of machine learning, I just introduce it with difference. Because sometimes if you have to work on autonomous, those of y'all who are in second year, who are very interested into going in entering in the field of robotics. Robotics come under the entire bracket of AI. If you're in mechanical, if you want to work something in mechatronics, if you want to come out with something which is as per the industry 4 standards using digital twins, then for training it you require machine learning algorithms. So all this to a certain extent are interrelated with each other. Well, now where do you find it? So this is what I told. This is something very amazing. Now you, most of y'all will be using Spotify every other day. Some of y'all might be using when lectures are going on because the musics are as per your recommendations. The songs which you hear, if you keep on listening to the same songs, you know that next time when you open it, your list of songs come on top in the search. So recommendations based on your usage using Spotify. The same thing in the case of Google search. If you're searching for a particular concept, you can see that the search happens much faster. There is a typo which fills up the search syntax so that your search becomes very efficient, much faster. And this is an important, the diagram over here is the one which was an eye opener for ML with AI, that is the autonomous driven cars. This was first found out in Stanford University. So for training that cars, it was really a very nice video which I saw, training the auto driven car. It has to be tested in different conditions. It has to be tested on a plain road, when the terrain is smooth, hilly terrain, when the weather conditions are varying, when there is a turn, when there is a signal. So these are the data sets which are given to the auto driven cars for training purpose, and then it was tested. So it went through rigorous training and testing phase before it became operational. Now it is actually operational in California, the concept of auto driven cars. Next comes the breast cancer detection. If you just see, this comes under the concept of health analytics. I've just got the diagram of breast cancer detection, but if you see, health analytics is one in which by the year 2022, it is going to hit your dollar market. It is going to touch around 133.44 billions by the end of 2022, because it immensely relishes on the concept of ML. It is all the MRIs for which you require your doctor to interpret it. Machine learning has got deep neural concepts, which is a subset of machine learning, and that deep neural is entirely concentrating on all the image scans. It is able to interpret from image scans. So you have different level of the GANN and convolution neural networks, which helps in interpretation of the medical data, analyzing it and suggesting recommendation to the users, and also identifying the things which is very difficult to find out with a lame person, or very difficult for the doctors to identify it in the first instinct. It is being substituted by machine learning algorithms. So these are the things which you can see in your day-to-day basis. It is visible in your day-to-day basis. Now, how is it different? So here I have been talking from the beginning, machine is learning. But you started with your programming. You know that you are quite capable in programming in C, C++, Java. You write the code, you have a code block, you get an output. It is procedural. You call up any particular this thing procedure, you execute it, you have an output. So how is it different from the algorithms which are being used in ML? The difference is, in your traditional programming, you have an input, you have a procedure which has to be followed, it gives you an output. For example, you have an input, take two numbers. The procedure tells you have to add two numbers. So you put it in a loop, or you have directly you have a adding notation for adding two numbers. The output which you give is the sum of two numbers. So that is what is depicted over here. You have a data, you have your rule. Based on the rule acts on the input and it produces an output. Now, how is it different from the traditional programming? In the case of machine learning, you have the input, you have the output. Say in this case, the input is given to you x equals 1, x equals 2. The output is given to you y equals 2, y equals 4. Input is given, output is given. But what you have to find out, you have to map the relationship between the input and the output. So, what is that? You have to generate the rules. What are the rules? The rule is, I think so, y equals x into 2. So that has to be generated. This is what is called as modeling a particular machine learning, fitting the model. In fitting the model, you just find out what is the rule which is to be generated if I'm given the input as well as the output. Machine learning is as simple as that. And it is this important difference which is between your traditional programming and your machine learning approach. The machine learns what it learns. It knows the input, it knows the output. It learns to generate the rules, which is mapping between the input and the output. So machine learning in future will automate jobs that most people thought could only be done by people. This was put forward by famous Dave Waters. So a day is going to come. You will have humanoids. You have to just pay amount for your humanoid. It will take care of the entire household, from cooking to keeping the house neat and tidy, to playing games with you, to sitting and chatting with you, your emotional dependence, playing games with you, taking care of you, reading aloud for you. So that is the future. Future of machine learning is towards humanoids. Already there is some physical humanoids which have come into place in countries like China and America, but India is still working on it because that is the one which involves lots of research and lots of funding to develop your humanoid. So that is the future of machine learning. Now, how does this machine learning actually learn? What are the methods of learning? So, machine learning is actually the learning portion of it is categorized into three broader categories. The first category is called as supervised learning. The second category is called as unsupervised learning. And the third category is called as your reinforcement learning. Now, supervised learning is how your teacher teaches your students. I'm taking classes for primary maths class for a group of students. I know tables, I know the basic additions, basic subtractions. I'm talking about on the school level. So when I teach the student learns. Now I test the knowledge of the student by giving a question paper to them. The student answers. So from the answer, if it is matching with the answer which I have in hand, it means that the students have learned the concept. So it is supervised. It is similar to a teacher teaching students because the teacher knows the output and it checks for the correct output. Whenever there is discrepancy, the student is expected to get full 10 marks for a max test. The student gets only 8 marks. It means that two sums he has committed a mistake. So that is the error. The student is made to write extra numericals on those two type of sums and then the test is repeated. This is learning by error correction. You are supposed to achieve a particular target, you are not achieving it. The difference between what you expect and what the student gives to you or the system learns and gives to you, That discrepancy is the error. This error is fed back to the system for rectification purpose, and the student learns from the error, and the student's performance is improved. In the same way, the system's performance also gets improved if there is minimization of error. So supervised learning trains algorithm based on example input and output data that is labeled by the humans. Now, what do you mean by labeling? Now, suppose say I need a machine learning algorithm to classify two things. It has to classify, given an image, it has to classify whether it is a dog or whether it is a cat. So the features of dog and the features of cat are the inputs given to the system. The output from the system is for these features, these are all the images which are images of cat. These are all the images which are images of dog. That categorization is being given by the user. So going back, the system is being given the input in the form of features. The system is being given the output in the form of labels. What has the system got to do? The system has got to find out the mappings between the input and the output. If the system is able to understand the mapping correctly, given an unknown input to the system, and it is able to generate the output which according to the user is correct, it means that the system has mastered in learning the categorization between the output. This is how learning gets accomplished in the case of supervised learning algorithm. There is another type of algorithm which is called as unsupervised learning algorithm. In the case of unsupervised learning algorithm, the output is not given, but the system finds out the patterns. It finds out by finding some association, by clustering, by finding out some commonness between the features. It is clustering and it is telling these are all the elements which can be grouped together. So that cluster generation is being done by the system. So such type of learning wherein the output is not given, the system has its own right to understand the data which is present, which is given as the input to it, and find out the patterns present in it, is called as unsupervised learning. So from the difference of the naming, supervised and unsupervised, we can understand in the case of supervised, the output has to be given to the system. And in the case of unsupervised, the output is not given to the system, but the system learns of its own. So a typical example of a supervised learning. Learn the rules between the input and output. It helps in model building. Input is given, the output is given. The system learns the model. The system's learning is completely accomplished when a known input is given and it produces the correct output which is required out of it. It is tested. So the system performs well. When the FE, that performance of the system is very good, when its precision is very good, the system starts functioning as a classifier. Any input given to the system, it is able to find out what is the correct output. So this is a supervised learning algorithm. So in a real-time scenario, how does a supervised learning example looks like? I have to model a system. That system has to differentiate between a water species and a water body. So it has to differentiate by different types of water species like shark, whale, fishes, seahorses, etc., etc., and the features of water. So an algorithm has to be fed with images of water animals or water species like fishes, like sharks, like whales, etc., etc. And there should be a series of images of oceans which is to be fed into the system. It can be a pond, it can be a lake, it can be any water body. Now, what should the system do first? So it has to differentiate. I give the input. The input is some images of water species, some images of water bodies. After that, what will happen? I give the output also. The images of water species has got its own labeling. The images of water bodies has got its own labeling. What should the system do? The system should learn how to differentiate between a water species and a water body. So from the input which is given, water species, it first extract the features and learns. Okay, if these features are given, the output is mapping with my output. What is the output? A water species. Then it takes the water body. It learns the features and it checks if these features are there, then it is a water body. So this process, when the machine is learning by itself, is called as the training of your machine learning algorithm. It learns by itself. So what it just maps, okay, if this is the input, this should be the corresponding output. So that process goes on and on. It in fact goes for so many training cycles. Sometimes if your configuration is not good, you're not working on a GPU, it might take even days for you for the machine learning algorithm to get trained. By being trained on this data, the supervised learning algorithm should be able to identify unlabeled shark images as fish and unlabeled ocean images as water image. So when you tell that learning is accomplished, it is able to create a model, and the output of the model is it is able to tell you that when an image is given, it is an image of object 1 or image of object 2. Then we can tell that the system has learned. So this example is a typical example of classifier. In this case, it is classifying between two things, the water species and the water body. The next type of algorithm is unsupervised. Unsupervised, as I told you, a chunk of data is given to the system. The system uses its own intelligence to separate the junk. Using its intelligence, there can be very many ways of identifying the patterns which is present inside the data. It will identify patterns, it can find out similarities, it can find out clusters. See, as an example, it can find out the commonalities between the input data. What are the similar features? How far they are close by to each other by means of some Euclidean distance. It can find out all the points which are clubbed close together. So, an unlabeled data are more abundant than labeled data, and these methods are very useful because you have to give the naming or labeling in the case of supervised data, but vast amount of data which is available is not labeled properly. So the first step in any machine learning is unsupervised. Why it is unsupervised? You collect the data, you find out the commonality of data, then you identify it, you label it, then the data becomes a labeled data, then it goes to your classifier and you can use it for classification and prediction purpose. So when I tell the students or when I talk about machine learning to anyone, I always tell you should master in unsupervised learning, because if your unsupervised learning mastering skills in your clustering, in your grouping is very good, you generate data for the classifier models. The goal of unsupervised learning is to discover the hidden patterns which are present inside your data set. Now just see a very layman example of it. So I expect some answers. Anyone can unmute and answer. So how many clusters do you expect from this particular combination? How many clusters can be there? Anyone can unmute and answer. Yes? So anyone can unmute and answer. The number of clusters, 2. Oh, I'm getting answers. Yash has written 3. Gauresh has written 2. And how about the other meet? Amog has written 2. Good. Anything else? Anyone else? Okay, 2. Swapnil 2. I get a vast collection of 2s. And in the other meet also, I get a vast collection of 2s only. Yeah. Can anyone unmute and tell what can be the clusters? In any of the meet, anyone can unmute and tell what can be the clusters based on this diagram. What can be the clusters? Yes? Yes? Group of similar data? Yeah, group of similar data is clustering, but on what parameters you're grouping? On what parameters? Anyone? Yeah, good. So 4 of them are spherical and 2 of them are cubical. Yes, I got one answer. But is that the only approach? Is that the only approach based on shapes? Anything else? Ah, yeah, based on. Yeah, so one more answer I got based on color. Based on shapes, based on color. Any other thing? Yes? Any other thing? What do you mean by it? Very good. But what is edible and not edible? Can I use that word edible? Yeah. So now what is your perception telling? Your perception, a small gathering of say around 50 or 60 persons have got different ways of looking at it. One is looking at the color and you're trying to cluster it. One is looking at the shape and you're trying to cluster it. One is looking at whether you can eat it or not and you're trying to cluster it. So this is the problem with the concept of clustering. The patterns are generated as per the perception of the person, the one who's looking into it. So I can have based on shapes, I have 4 which are belonging to a spherical shape and 4 which are rectangular in shape. Based on color, I can categorize it. Based on the background, I can classify it. So 4 are 2 are having a different background, the other 2 doesn't have a background. There are very many ways of categorizing it. And why it is very important, because if I find out a pattern, now what happens exactly if some features are picked out from each and every object? We can see that for 2 objects which are close by to each other, the feature points will also cluster together, they lie together. But if I see that there is an object which doesn't fall inside any of these patterns, that object becomes an outlier. That is very, very important using machine learning or any data mining approach. Outlier analysis. So, what is outlier analysis? You know something doesn't fall inside the group. You have to analyze why it is not falling inside the group. Is it something we have to worry about, or can it be discarded? So the outlier analysis is an outcome of this different clusters or patterns which are generated because of this unsupervised learning algorithms. The next type of learning is a reinforcement learning. This type of learning is invariably used in robotics. Now, what is this type of learning? It is not completely supervised, it's not completely unsupervised. It is a mixed breed of both. It has some rules in it. For example, if you take this particular agent, which is a robo, It is being told to the agent, some rules are written. That is, if you go near the fire, it will hurt you. So when the agent moves near the fire, it is being punished. The points reduces. So the agent learns that next time it has to be avoided. So the rules are given. The agent has to select an action based on the rules or policy, and the output of the action, it can be either a reward or it is a penalty. It is a reward means that it's moving in the correct direction. It is a penalty means that it is not moving in the correct direction. Now, what is being learnt in this case? These policies or rules are being learnt in every case. And it iterates till your optimal policy is being found. So, this base is for all the games which are being generated. You play chess with the system, you play checkers with the system, you play that maze game with the system. How it learns? It learns based on the concept of reinforcement learning. Most of y'all keep playing, but how that playing, how it has been programmed. If machine learning is incorporated into that programming, it uses a concept of reinforcement learning for the system to learn the tricks and trades of playing a game with a user. Okay. Robot navigation. This is a real-time example. Robots run Amazon's warehouse. Amazon, what happens? The number of purchases, it increases. It is very rapid. You have per second purchases across the globe. Is it possible for fetching all the items which are present in a warehouse, getting it, parceling it, putting it to proper person's address? So in such cases, these robots are being used. The robots are programmed. It knows from which position, from which track it has to take the object, put it, parcel it, send it to the appropriate place, billing it, and sending it to the appropriate places. So this is being used in Walmart's. It is being used in Amazon's warehouses. Not in India, but it is being used abroad. Now, how does the machine learning process exactly? So till now, I have given you all so many examples. But in a nutshell, what happens? I take any type of learning. Say, I'll give you an example of supervised learning. I need to distinguish. I need to classify. Classify what? I need to classify between two images. Images of dog and images of cat. Data collection, first phase. What is being done? You just collect what the images which you have to model your system for classification. Next, data preparation. You know that you have some images of cats and images of dogs. Is the images clean? Is the background clean? Are you able to pick out the features? In that case, what are the features which are specific to cats and what are the features which are specific to dogs? So you do the data preparation phase. Next, you give it to a system. The system learns. That is called as model fitting. What does model fitting do? The first image of cat comes, the parameters are attuned, and it checks with the output, okay, it is a cat. It takes the second image, it changes the weights. Now, what is happening? You have a process that wherein the learning accomplishes by updation of weights. So the system learns. Finally, after all the input patterns are given, it learns again, it revises. See, when you learn for your exam, what do? You keep on revising. Likewise, the system also revises. That is called as epochs. It revises 10 times, 100 times. How do you know that it has learned? It sees the discrepancy between the error. If the error percentage is very less, it means that it has revised, it has learned. But how do you test it? The system is being given some samples. That samples, you know the output, but you check for the output which is generated by the system. If it is mapping, it means that the system has passed the test. Now, once the system has learned, then what you do? You use it as a model. You give your unknown input and you use the system for giving the prediction. A typical example, when you go to college, you see most of the faculties you have biomedical sensors. It can be a sensors using your thumbprint, or it is a sensor using your face recognition. How it happens, the system learns. The system learns from the features which is extracted from the face, or with the features which is extracted from the thumbprint. Then the model evaluation and hyper parameter tuning is how are you to increase the same thing. When you pass the test, you get 80%. What should I do to make you get 100%? You give additional revision. That is your hyperparameter tuning. And model evaluation is checking. You give your unknown sample, you check for the output, model evaluation. Hyperparameter tuning, how to increase your efficiency of the model so that the error percentage is minimized. It becomes literally zero. So this is in general, the machine learning process. It can be fitted for any type of algorithm. It passes through these 5 steps. Now, very important applications. So looking at the concept, you know that you can have applications based on supervised learning. You can have applications based on unsupervised learning and reinforcement learning. So based on supervised learning, you can have any type of classification. One typical example of classification between cats and dogs, classification between water species and water bodies. So image classification. It is used for diagnosis. Given an object, breast cancer, that MRI scans, it is able to find out whether it is malignant or not. Diagnosis. It is also used for fraud detection. You have a list of transactions. These type of transaction or legitimate transaction, a certain types of transaction is a legitimate transaction. So when a model is fed with so much of data between legitimate and illegitimate, it is able to find differentiate between the both. Now, I told you supervised learning, the output is categorical, labels. But if the output is also a number, it is called as a regression analysis. Most of the regression analysis, it comes under time series. For example, weather forecasting. Last couple of days, the night temperature is so and so. So what will be the weather of the next couple of days? So the output is a numerical value. So if the output is a numerical value, you call it as regression analysis under supervised learning only. Similarly, if you want to find out the estimated life expectancy or stock market forecasting, all these things comes under your regression analysis. Then you have unsupervised learning. Unsupervised learning, you can do wonders with unsupervised learning. First is targeted marketing. You would have noticed that when you just browse for some purchases in Amazon or Flipkart, you just eye on certain things. You actually do window shopping. You don't go to buy. You just put in your cart, but you don't buy. What happens whenever you open up the web page? You get the ad flashing for a couple of minutes, tempting you to buy. This happens for everything. If you're booking flight tickets, if you book for movie tickets, if you anything, if you want to e-commerce site you're using, customers are being targeted, and they are being tempted to go and buy the products. So that is a typical example of clustering. A recommender system, the music which you like, the web page you want to see, the books, who are all the users who have read similar books. So it recommends to you. Similarly, it is used for visualization. What are the different types of plots you want to see the data? If you know that your data is very, very massive, the important crunches of data alone is being presented to you by a concept which is called as dimensionality reduction. And finally, in reinforcement learning, everything to do with AI in game theory, in real-time decision making, in robot navigation. Whatever the system has to learn as a policy through reward and punishment happens in the case of reinforcement learning. So in computer domain, especially, it is being vastly used because one of the key area of machine learning is computer science. So, starting with image recognition to medical diagnosis, stock market prediction, online fraud detection, personal assistant, your Alexa, your Siri, all these things uses machine learning algorithms inside it. Now, in healthcare specifically, it is used for disease identification, it is used for drug discovery, it is used for personal medication, it is used for predictive analytics, it is used for prediction of disease. So, all these things, like during the vast amount of COVID data which was generated during the last 1.5 years, the all the journals were made free of cost, and all the data sets were thrown open to public because they had to research. If you see the proper research pertaining to the different waves of COVID, the first wave, second wave, and third wave, the statisticians of IIT Kanpur have done a wonderful work because they were exactly able to predict what will be the onset of the second wave and when it will come to a end. Now also they have predicted that the onset of third wave, but it's just a wait and watch. If the wait and watch it happens, it means that that prediction algorithm is working the best. What it is used, it's using only machine learning algorithms for it. Typical example, Pfizer using IBM Watson on its immuno-oncology. This is a typical example. It goes to the level of genes, gene editing it does. And it finds out for a specific human being based on the genetic composition, can a medicine be prescribed to a single person? Now, if you're having diseases like sugar or diabetes or BP, you go in for generic medicines. That is, for BP, a set of medicines are given, irrespective of whether your body is getting attuned to it or not. It is a sort of generic medicine. But what is the research direction going as of now is precision medicine. Because of machine learning algorithm and genetic engineering, specific genes of an individual are being tested, and medicines are being discovered for a single human being. So that is the power of machine learning, which is used in drug discovery. Personalized treatment for finding genetic markers and genes for a specific treatment or medication. This is happening in a very prominent genetic engineering lab in US, which is called as Genetech. So it is personalizing the treatment based on the individual genes to precision medication for a single individual. Now I have told about health. What about finance? In finance, right from financial monitoring to fraud detection to giving investment this thing yeah, this thing investment predictions to risk management, everything machine learning is being used. In reality, this is the exact picture what I am telling. For fraud detection, Citibank has collaborated with Fedzai to identify online and offline fraud. It has actually happened because I have a personal experience of it. Once when I had to buy a jewel from a shop which went for some 2 to 2.5 lakhs, before I could process the transaction, I got a call. Is it a legitimate transaction or not? How it is found? From the list of transactions, whenever there is a purchase, when the amount overshoots a particular figure, and your card has got a particular limit, the system immediately sends alerts. So from that alerts, the person is actually tracked and found out whether the purchase is legitimate or not. So such banking sectors are using machine learning for this fraud detection. Similarly, PayPal uses it for finding out money laundering. What are all the places unnecessary money transaction takes place, whether it's legitimate or not, it is incorporated in PayPal. Wells Fargo utilized machine learning for targeting customers who are based on the purchase of buying, what are all the advertisements which has to be targeted on specific customers is being devised. Similarly, the future of machine learning when compared to ML, when compared to finance, is automation by companies like Betterment and Wealthfront to provide investment decision. You have investment persons, investment managers. So those roles will be knocked off, and we will have chatbots and inbuilt decision making chatbots which tell you this is the best place to invest. So that will be the future of machine learning when it comes to finance. What about retail and product recommendations? How many of you all watch Netflix, YouTube, Amazon? The movie recommendation comes to you based on the previous movies which you have viewed. So Netflix is one which is really performing very well. In fact, it's performing way better than Google with respect to its recommendation engine. Its recommendation engine is very good, and the engineers in Netflix are the ones who are paid the most because of the immense amount of research which is being done in AI and ML in Netflix. Another thing is your chatbots, your conversational chatbots, your Apple Siri, Alexa, Google Virtual Assistant. It uses a vast amount of NLP, natural language processing, for understanding what the human beings talk to them and replying it and performing the task. So nowadays you use the Alexa for everything, for switching on the fan to switching on the ACs to playing the channels which you want to answering. In fact, I know kids who have Alexas at home. They do the calculation. You just ask Alexa what is 5 plus 5, and they do the calculations using Alexa. So this is the level of your NLP which is being used for your chat box, which are becoming more popular. With every version of it, the features of it also increases. If you go for dynamic pricing, you would have definitely witnessed when you use Ola or Uber, based on the day of travel, the place of travel, the traffic, and your pricing will be different. So how is it? It has got an inbuilt optimization engine which optimizes the different parameters, and it gives you a dynamic pricing. Uber is very famous in US, and you have so many people who do this carpooling based on it, based on the direction in which they have to do, based on the time. So carpooling is also being done. The optimized prices is being generated and given to them. And this TripAdvisor focuses on analyzing brand related reviews. So the most of the hotels, most you would have seen ads also, your trip advisor, then you have your Oyo Homes. All these things works on recommendation and works on the feedback which we are given to them, the ratings which you are giving to them, whether it's a positive rating, negative rating. So you're able to sell your brands, you're able to improve your services. And for all this, what is the key in making them understand, learn things dynamically? It is only machine learning which revolves around it. Now, another thing which you will be using in social media. What happens in social media? You have Facebook tagging. Initially, the tagging, we had to do the tagging, but if of late, the versions of Facebook, you have a concept of auto tagging. It is a very important application of image recognition. Image recognition is also used for unlocking your smartphones, unlocking your laptops, and it is using a concept of artificial neural networks in it. Not only Facebook, all the social networking sites, your LinkedIn. Your LinkedIn uses an immense amount of ML algorithm and suggests whether you should apply for your next job, and whom you should connect with. So for that also, machine learning algorithms are being used. So if you look into it, that's what was the first commitment I told when I began to speak. If you look into ML, where it is, what it is, you'll end up seeing it is present everywhere. It has creeped into every part of life, with your knowledge or without your knowledge. So this is the power of ML. Now, what is the future? There is no future without ML. Future cannot be imagined. It is into every part of your life, starting from morning till you go to bed. Whatever you use, wherever you go, ML is creeped, and the creeping is becoming prominent every other day. So I just tap your realization that this is the importance of the subject, to develop further, to come out with your own applications and help the society, machine learning society. Now it is left up to you to take it further. So that's all for me. So any other queries, you can just ask me. Any queries? Yes, any queries? Yesh has asked, ma'am, could you recommend some intermediate level courses? So yes, you can, if you're interested, just go to the basic courses of machine learning from Coursera. It is very interesting, and you just get a hands-on to work with it. Uh, some knowledge of Python is also required. Coursera courses are the best because you have from Udemy also, but I personally prefer courses from Coursera. What about the accuracy of the output in ML? So once again, I think so. Is it 100%? It is not 100%. Obviously, it is not 100%. You can't have a system which is 100% efficient, but you can arrive at a system which is more than 90 to 95% accurate. But that depends on the domain which you are working. If you're devising your robot which is able to assist you in a surgery, obviously you have to look at 100% efficiency, because the precision is very, very important in that particular domain. But if your domain is for recommending books to the users, you need not look at 100% efficiency. So efficiency is domain based. Am I clarifying your question, Yash? Yeah. Any other queries? Yeah, Priya, I'm just winding. I think so. The students should be satisfied with whatever I have told them. Priya?
Yes, ma'am. I guess students got a lot to learn now. Suchita, ma'am. Yes, Paul, sir.
Yes, yes. I would like to acknowledge and render my sincere thanks and gratitude to all the people who have been instrumental in accomplishment of today's webinar on machine learning and its implications in the real world. First and foremost, my sincere thanks to Anuradha ma'am for making all of us understand the core ideas of building systems that have the ability to automatically learn from data and improve the experience without actually being explicitly programmed. Thank you, Anuradha ma'am, for strengthening our students' machine learning foundation and making them stand ahead of the others with emerging applications of machine learning. I would also like to make a special mention and appreciate our own SFIT NDLI club members for organizing this webinar under the able guidance of Sucheta ma'am in the absence of Chinmay ma'am. Thank you, dear NDLI club members, for your contributions towards organizing this webinar. And thank you, dear participants, for being there and learning from today's webinar. You all will surely be ahead in the game of machine learning, which will be for life. Thank you and have a pleasant weekend.
Yeah, thanks once again for your patient listening. And any queries, any suggestions, you can just ping to me and you can mail me in my SFIT mail ID. Thanks a lot, students. And thanks, NDLI team, for giving me this opportunity to just have a talk with the young students so that I will be able to give them some good foundation based on this particular important subject. Okay. Thank you.
Thank you, Anuradha ma'am, and
Thank you,
to
ma'am.
all the
Yeah.
students.
Also, students, please share your feedback. I have shared the link in the chat box. So please go through it.